All right, scientists, we're almost there. We've got drop-down menus indicating whether or not students have taken certain actions during passing time, and ifs formulas to add time to the amount of time they've lost. If they do take those actions, time they will not be able to use to move. Now, what we've done so far is just set up inputs, okay? What they're doing. And then over here, I've started with a velocity of 1.4, which is the average velocity of a walking ninth grader, a passing time of 420 seconds, which is 7 minutes, what we currently have. If you change it later and you want to look at 5 minutes or 4 minutes, that would be 500 or 240 seconds. And a distance to class. And this is the distance from my class to Mr. Peters' class. Okay, 93 meters. Now, this is all the information we've entered into the spreadsheet, or we've set up the spreadsheet to interpret the information we've entered. Okay? What we want to do now is write some formulas that will allow that information to be used to determine how far the student can actually go in that amount of time at that velocity, and if they do that other stuff too. And we can compare that to the distance they need to go to see if they're going to be on time. So to determine if a student's on time, we're actually not comparing times, we're comparing distances. The theoretical distance they could go versus the distance they need to go. Okay? So we're going to look at writing formulas now for the added time, the travel time, the distance, and the result. Okay? Now, this formula in cell B8 is really easy. It's just the same number that you get down here in cell H13. Okay? So to write this formula, I'm just going to put an equal sign, and then I'm going to put H13. So I always want that cell to be equal to whatever it says in H13. Now watch what happens. If I say, okay, yeah, the student does go to the bathroom during break, and they do go to their locker, that adds 132 seconds to the time that they don't have to move, okay? And notice that number appears over here. All right? Now, travel time is the time we're actually going to use to calculate the distance they can go. Remember, distance is equal to the velocity an object's moving at, if they're moving at a constant velocity, multiplied by the time they move. The travel time is equal to the passing time, which is how much time between bells there is to move from class to class, minus the time they're not moving. They're doing other stuff. So that's the actual time they're walking, running, jogging, whatever they're doing to get to class. So this is another formula just involving arithmetic. You start with an equal sign, and then we want the cell with passing time minus the cell with added time. We're not going to put 420 minus 132 because those numbers will change, and we want our model to respond to those changes. So we're going to put the cell that includes passing time minus the cell that includes added time. And as those numbers change in those cells, the spreadsheet will still be able to calculate the travel time. Okay? So I can click on cell C4. I can put a simple minus sign for subtract, and then I can click on cell B8. So now my formula says, hey, take the number, whatever it is, in cell C4, and subtract the number, whatever it is, in cell B8. Boom. Hit enter. 288 seconds. So this student has 288 seconds to actually get from my class to Mr. Peters' class. Okay? Which is less than the 420 they have for passing time. And finally, we want a formula in cell D8 that calculates how far they can go. And remember, they're moving at an average constant velocity. Okay? So we're going to use the simple formula distance is equal to velocity times time as the basis for the formula we write in the spreadsheet. So we want that cell D8, to be equal to the velocity they're moving at multiplied by the time they move. So again, I start with an equal sign, and I click on the velocity cell. Okay, so B4 is where we'll have the velocity. Now, as I change the velocity to model different situations, it'll change the calculation. I'm going to use Shift 8 to type an asterisk, because we use an asterisk in spreadsheets to indicate multiplication. And then I'm going to click on the travel time. Hit enter. There we go. So in this scenario, okay, it says they can travel 403 meters at that velocity given the time they have, which is easily enough to make it to class on time. Okay? Pretty simple. Now, we want the spreadsheet to actually tell us, based upon the numbers that come up in the outputs and compared to the numbers that we have in the inputs, whether or not the student's going to be on time. And we're going to use, for that, in our result, another ifs formula. Okay? Remember, ifs formula has the spreadsheet look somewhere else to see if something's true, and then puts a value based upon whether or not that's true. And what we're going to look, or have the spreadsheet look at, is whether or not D4 is greater or less than D8, or whether or not the distance to class is greater or less than the distance they can theoretically travel, given what they've done, how fast they're going, and how much time they have. Okay? So we're going to start with D4 being greater than D8. And we're going to use the greater than sign here. Okay? Now, if that is the case, if the distance they have to go to class is greater than the distance they can actually travel, they're going to be late. So that's the thing we want the spreadsheet to determine if it's true, and then we want a value based on that condition. And the value is going to be a word, okay? And I'm just going to type in, or a set of words. Uh-oh, you are late. Note, I put that in quotes because it's words, and that'll let the spreadsheet recognize those are words. Okay? So far my formula says, hey spreadsheet, look at D4. Is it bigger than D8? That's true. You're late. Then I'm going to do the opposite. What if D4 is in fact less than D8? That means the distance they have to go to class is less than the theoretical distance they can travel given the inputs. Okay? In that case, they'll be on time. I can write nice job. You are on time. Again, put it in quotes because it's words, and that's how we get spreadsheets to understand words. And I hit enter, and my spreadsheet reports a result of nice job, you're on time. So in this case, we're modeling a scenario with a 7-minute passing time, a student taking those two actions during passing time and moving at a velocity of 1.4 meters per second. Our model tells us the student is going to be on time. Okay, now, part of the thing we're trying to do here was answer the question, was 300 seconds or 5 minutes, 240 seconds or 4 minutes enough time for passing time, given what students have to be able to do? Going to the bathroom is a legitimate thing to do. So is filling your water bottle. Okay? So is going to your locker. So let's say the student takes all of those actions. All right? In a 7-minute passing time, they're still on time. Okay? They can still travel 368.2 meters and get to Mr. Peters' class. Now, let's say they have a 4-minute passing time. By changing this input, I'm changing the travel time. They have less time to move between classes, given what they've done, which are all legitimate things to do, and that might change their results. So when I hit enter, they're still on time. Okay? If they had stopped to check their socials, on the other hand, then they're late. Okay? So you can change your inputs. You can model different scenarios with students doing different things at different velocities for different passing times, going to different classes. Okay? Even if they didn't check their socials and they were trying to go to, say, art class, which is 137 meters away, they would have been late. All right? With a 4-minute passing time, doing completely legitimate things during break or during passing time, they wouldn't have made it. All right? Hope this helps.